Let's give them examples of hyperparameter tuning. Now, the goal of hyperparameter tuning is to address the bias variance trade-off. Remember, if you have a lot of bias, it means it doesn't fit the current data well, whereas if you have high variance, it doesn't fit new data well. And then when you're evaluating the bias variance trade-off, there's a couple different methods depending on which model you're looking at. So example evaluation methods are precision, recall, area under the curve, ROC curve, R squared, mean squared error, etc., etc. So in some models, you do get parameters that you can tweak. For example, when you're looking at, say, lasso regression or ridge regression, you might have an alpha parameter that you can increase the size of, which will penalize different coefficients more heavily or lighter, depending on what your alpha value is. And then there's a couple different tuning methods. One is grid search, where you have a predetermined list of values, say that alpha value that I mentioned earlier, that you're going to test. And you're going to see the performance, the bias variance trade-off for those different predetermined values of alpha. Second tuning method is random search, where you just choose random values of alpha and see which one performs the best. Third tuning method is Bayesian optimization. So based on previous values and how those previous values perform, you're going to gain information on which values to try next. So if you had large values of alpha that performed well previously, you may continue searching only large values of alpha, as opposed to random search, where you're just trying random big values, small values, medium values, etc. And finally, you have the genetic algorithm, where you go through several generations or waves of value search. And then you take the best performing values of those searches, add a little bit of noise to those good performing values to inform the next generation of value searches.